of our first day. Please go ahead, Danielle.
So thank you for coming back from break. I appreciate seeing more people in the room. And it's my pleasure to chair this session where we're going to get a fantastic plenary discussion on high variable renewable energy, our future and a way forward. First, I just want to introduce myself. I was here at this meeting last year, but I'm not a regular ESIG attendee yet. So many of you who are new, we might not have met, and many of you who come to these regularly, we might not have had a chance to meet. I'm Danielle Merfeld. As of 2 weeks ago, I was a GE long-term employee, 23 years, spent a lot of time with our energy consulting team that's very heavily involved in ESIG. And I'm now 2 weeks into a new role as the Global Chief Technology Officer for Qcells. So still very much interested and engaged on the system integration piece, but without the wind-centric focus, now more of a solar-centric focus. So I'm learning, it feels like a whole new space, but it's all still renewable energy. I want to set the stage for this dialogue that we're going to have just by reminding everybody about things that I'm sure this room is pretty familiar with, in that renewable energy is expected to make up about 90% of our global energy electricity generation by 2050, according to the IEA, if we hope to achieve net zero emissions. So most of that renewable energy is going to have to come from renewable, variable renewable sources like wind and solar, because of the constraints on more dispatchable renewable energy generation, like hydro, geothermal, things that we in GE would work on quite a bit as well. Now in 2020, renewables share stood at 29% globally. And however, the variable renewables section of that was only 9% of the total. So that means we are in for a really significant growth of variable renewable energy over the next several decades, especially because at the same time that the mix needs to change, which we've heard a lot about today with variable renewable going from 9% in 2020 to about 70% in 2050, the amount of electricity that's going to be generated or need to be generated is almost tripling. So this is a huge change in the sector, and it's causing a lot of transformation. And while this energy transformation, the energy transition is really broad, and it's got a lot of different components to it, I would argue that this rise of the variable renewable energy is by far the most critical facet of the challenge this decade. There's a lot of important things happening, and there's a lot of groundwork that we need to lay for the future challenge of that last 10% or those infrastructure development pieces that take a long time. But right now, the focus is on decarbonizing our energy resources. And it's a combination of electrification and cleaning up the electricity supply, as many of you already know. But if we don't do that in this decade, we're not going to be on track. We won't be able to hit the goals of the Paris Agreement. So with that challenge and that focus of this important decade ahead of us, I gave a talk here last year that was focusing on the system of systems challenge that really makes this up. This is the part of the challenge around the energy transition related really to the grid. And I'll warn Alice, after such a great keynote, you're going to get asked to come back and do a follow-up plenary maybe. But it's a great opportunity because in that talk, I highlighted 3 simultaneous transformations that the grid was going to have to go through. The physics, the operations was also going to have to transform, and the economics or the market surrounding it. And it's very close to the people, processes, and physics that you heard during our keynote today. So I think there's these themes of transformation and the theme of urgency and how fast these radical transformations have to happen. I wrote up a summary of that session last year and put it on a LinkedIn article just last week, just to try to maybe summarize those points and kickstart the discussion. And I got some great feedback. So I'll be incorporating that into some of the discussion. I'll weave it in here this afternoon. And I just want to say, I offered some broad brushstrokes for some of the changes that needed to happen across the grid mostly. And today's plenary discussion, in contrast, we'll dig into some of the specific areas where we're starting to see a clearer path forward. So we'll cover some challenges, some opportunities associated with this move to a high variable renewable energy power system future and decarbonized energy future. And to enable that conversation, we've brought together some very insightful voices in the sector to provide a range of perspectives and real life examples from their work. You've already met Alice Jackson, who gave us this fantastic keynote presentation just not even an hour and a half ago. She's drawing on her experience leading the system strategy and planning for Xcel Energy. Next to her is Jaquelin Cochran, who's the Director of Grid Planning and Analysis Center at NREL, whose work has focused on the evolution of the power grid with high deployment of renewable energy, so perfectly aligned with our topic today. She also led the LA 100 or the Los Angeles 100% renewable energy study, among other sort of significant global analyses. And I think she's going to be bringing some key insights around what this all means across a range of issues like resource adequacy, critical models and tools, and even supply chain. And then rounding out the panel on the end, we have none other than Debbie Liu, who many of you know from her role here as Associate Director at ESIG. And given her prior experience as a senior technical leader in GE Energy Consulting at NREL, she was embedded with HECO as they were undergoing really some big challenges in increasing the variable renewable energy on their grid, and as chair of IEEE's Power and Energy Society's Wind and Solar Power Coordinating Committee. I don't think there's probably a thing we're going to talk about that an area of this challenge that she hasn't explored in some way. So I would challenge all of you for the time that I'm asking questions and we're having the plenary, be thinking about what else you would want to hear from, because we have maybe an unprecedented range of skills and expertise that I think this is going to be a great conversation. I've been looking forward to this for months, so this is going to be really fun. Again, I'll save the last 15 minutes or so, and I've heard that since we started a bit later, we'll go a little bit later, so around 5 is when I'll try to transition. And I'll ask the first question up here, and then I'm just going to sit down and join them so that we can have more of a conversation. And this first question is a broad one, and I would ask everyone to sort of use it as an excuse to sort of give a broader background, a little bit more of an introduction on yourself. Alice, we've heard some good stuff from you, so you can keep it short, but I'd love to hear you dig in deeper on one of the topics as well. So maybe we'll start with you, Alice, since I know you've just come off this range of topics for us. What do you see as the most critical challenge to overcome to enable this power system with high variable renewable? And I'm going to challenge you because you listed a lot of things. And it can also just be more broadly the decarbonized power system. It doesn't have to be thinking about it at the transmission level or wind and solar from any specific facet.
Testing. Okay. So I actually had somebody ask me the question of the 3 that I had listed: the politics, the people, or the policy, the people, or the physics. What's the hardest? I'm going to go a little differently than that, though, because you asked more about the systems piece of it. So I told that person the politics, by the way, if anybody's curious. But as far as the systems pieces of it and what do I think is the hardest to transition, I really do think it's going to be that distribution system. And figuring out how do we have the appropriate level of visibility and communications in order to balance out the variability that we're going to see on that system. I mean, if you think about it, it is the ultimate component where you have everything that can potentially come in: localized variable energy resources, how customers actually use the system, increased utilization from an energy perspective with the electrification potential that could happen. I think that animal is the one that's the most difficult and has a lot of need for focus in order to figure out what are the things that we need to foundationally be successful.
Sounds great. Jaquelin.
Hi, I'm, since we were asked to give a little intro of ourselves, I'm the director of our NREL's Grid Planning and Analysis Center, which along with Ben Kropowski and the Power Systems Engineering Center are the 2 centers at NREL that have the most alignment with the work being done with the ESIG members. So thank you very much for having me and inviting me on this amazing panel. When, you know, in our center and at NREL, we're looking ahead at the grid of the future. How's the grid evolving? What are the challenges and opportunities? And especially as it relates to the people side of things, the other sectors, electricity markets, you name it. You know, there's a whole lot that the grid is interacting with that we're trying to capture and better understand. And I would say that with the biggest challenge, I mean, like Charlie was just showing, like the costs are down, the benefits are high. We've got all these examples in the world where they've already got high levels of renewable energy on the system. We know we can do it. How do we do it at scale and speed? that to me is the big challenge for us. It's like, well, we can do a model of the 2035 system or 2050 system, but how does that actually translate into getting investments made? And we can talk about interconnection queues and other things like that, but what we're trying to do, at NREL side to address this is thinking about like, how can we help give more confidence to people's decision-making in case, for area, how can we give the information as people are grappling back and forth with trade-offs? Can we better capture what they're concerned about and help hasten that sort of decision-making? And then how do we do this in all these different locations at once? And that brings me to like a very related challenge, which is, how do we also do this in a very thoughtful, deliberate process when it comes to community stakeholders? Because we know there are all these people out there who have very strong opinions about how reliable their electricity is going to work in their home, or what the price of the bill is going to be, or what technologies they love or hate, or, is their kids' asthma going to go away when they close different plants? And so people want to be part of this conversation, and we know that they are the ones going to be leading a lot of the change in their areas. And so how can we kind of speed up the analysis side so that that's not slowing things down, but be more thoughtful and deliberate in learning from the community? How can we, like at NREL, we're trying to think about, or what are the questions people are asking so that we can better answer that? There's a lot more listening going on. And then I would say finally, the big challenge to me is the climate change uncertainty, because we're trying to model all these different weather events in the system and what our resource technologies are going to be, what the availability is. And we can plan for these extreme events, but how often are these extreme events going to be? That can change the calculus of what courses we might want to take. And so that, given that we already have a lot of pause on investment decision from uncertainties, that just adds a whole layer of uncertainty that's can be challenging to capture.
Thanks. So I think the most critical challenge is building the infrastructure that we're going to need for the transformation. And the infrastructure spans from the huge amounts, Charlie talked about 1,000 gigawatts, of clean energy generation on the bulk power system side, to the huge amounts of new electrified loads on the distribution side. And I think today what we're seeing is a confluence of factors. So first of all, we've got this old aging infrastructure, right? A lot of this stuff was built like 1960s, 1970s. The stuff is as old as I am, right? It needs to be upgraded. So we've got a lot of aging infrastructure. We're moving to a more weather dependent system. So that means we want our grid to be bigger than the size of weather systems. So we need large amounts of interconnectedness. We just passed the IRA, and Charlie talked about that. It's going to increase the pace of wind and solar installations by several fold. And also it's going to increase the pace of electrification for transportation, for buildings, for industry, which is going to stress the distribution system. And then right now it's really hard to get anything built. And I'll talk a little bit more about transmission, because Alice talked about distribution, and I agree, distribution is a huge thing. And so, but I'll talk about the transmission side. So, right now we're lousy at building interregional transmission, right? I mean, today you think, oh, I only need interregional for those extreme weather events, but studies show that for tomorrow, we're going to need that interregional transmission on a daily basis, on an hourly basis. And in order to have these grids that are bigger than weather systems, we're going to need to overcome parochialism. So we're also used to thinking about our own utility, our own state, our own, piece of the puzzle. And working with our neighbors is something we're going to have to get better at doing. And there's some, potential signs of progress with like MISO and SPP coming together on JTIQ and things like that. But we're going to need to get way better than just that. And it's funny because, cost allocation is such a big problem. It's like the main problem in trying to get things built. And in the end of the day, that transmission is enabling cheaper costs for reliable, clean electricity. So it's sort of like we're cutting off our nose to spite our face by not being willing to spend the money. Generator interconnection, Charlie talked about that also, huge quagmire, and quagmire is like an understatement. I mean, there are words I could use, but not in mixed company. So, you know, to some extent, our generator interconnection process, as you know, we're using it to replace what we should be doing in regional planning processes and interregional planning processes, and the costs are being assigned to generators rather than to, you know, the large numbers of folks that the transmission actually benefits. And so generator interconnection is a huge thing that needs like severe overhauling, and, you know, hopefully we will see some movement in that. And, you know, we need to rethink how we do our transmission planning, right? So within, you know, the utilities, you've got your folks working on the reliability projects, folks working on the economic projects, folks working, economic regional projects, folks working on the economic interregional projects, folks working on the generator interconnection projects. We need to figure out how to integrate that. So sort of like what Alice was just saying about integrating across system planning, you know, we also need to integrate across the different silos of the transmission planning piece. I realize I'm taking up a lot of time, but can I just make two more? Of
course, yeah. We've got time.
I think we need to be more proactive, and we need to balance that with the fact that it's really hard. Stranded asset risk is a really big deal for regulators, and we need to balance our proactiveness with stranded asset risk. But I think that at the end of the day, you know, if you're going to err on one side or the other, I personally think a little stranded asset risk is going to be okay, given that the risk of underbuilding means you're not going to reach your clean energy targets or electrification targets, and you're going to spend a lot more to build local resources to replace the wires. So I think we need to think more about, you know, approaches like what ERCOT has done with CREZ and what the UK does with Connect and Manage, be more proactive in how we build. And I think also being proactive on the distribution system is key too. And then I think also, along with all of this, we need to get better at planning under high uncertainty, because the uncertainty of the future is huge, and we need to rethink how we do that kind of planning.
That was fantastic. We have a good whole plethora of buffet options here for topics. And I will say this, a very naive question that I had on our list earlier was what's more challenging, permitting or regulatory versus technology? I think everybody sort of made it clear, if not through their public remarks, through their dialogue, and even through previous public remarks, that technology is not the challenge. But I'm going to turn this question around and ask it a little differently, though, because I'm going to break it into two questions. And the first one is maybe a little bit more pedantic, but is important as well. From a technology only perspective, although we know that technology isn't the tallest, longest pole in the tent from a challenge, what do you think is the top technology challenge? And I'm being vague in terms of the landscape, so it gives you a little freedom to pick your arena. But who wants to start with that one? I'd love to hear from each of you on that one.
Okay, hopefully now this one's on. Yay. So from my perspective, the biggest technology challenge is one that we've been pretty blunt about since we made the announcement of getting to a zero carbon system. And that is, what is the technology that's going to provide the fill the gap needs of a zero carbon dispatchable resource? So when you think about the zero carbon resources we have on the system or the opportunity today, you're talking about, you know, pumped hydro, but once again, it's dependent on a lot of different things. You don't have your pile of coal out there. You don't have your pipeline of gas that you can call on. So it's a different animal. You have nuclear. And I would say no historic nuclear is going to be built as new going forward. You might have some advanced nuclear coming in, but once again, you have questions around, you know, how dispatchable is it? How much range do you have? But so to me, to get to the zero carbon system, we have to fill in the gaps that we haven't solved yet on what is that zero carbon dispatchable. Is it carbon capture and sequestration storage? People have very emotional responses to that one. And we've yet to see it happen economically on a broad scale. So there's challenges there, but to balance the system, that is the one I would say is from a technology standpoint, we haven't seen a economic, technologically opportunistic, outcome that I would sit there and say, this is it, let's go. So that is what I would put out there is the continued item that we have to address.
Great, thank you. You just leave it on, yeah.
I still don't know how you isolate the technical from getting the right regulatory and market investment drivers to make sure the technical is there when you need it. I would echo Alice's point about not having the certainty about what the technologies will be on the firm capacity for high renewable systems. The biggest open-ended question that we had with LA, because so many people wanted it, was multi-day demand response, because folks who did not want hydrogen really wanted a way for the customer side to be able to control the costs. And that's really hard to do for a utility to reliably count on major, like Matt, this is not just for your EV charging and day-to-day stuff, but for when you have when things go really wrong on the system and the transmission's down and you've got a drought or heat wave or something's going on. And so how you manage that technically is not clear, but for sure it's not clear how you would get the right market and regulatory structure to get people to commit to reducing demand during those times. But that's a really fascinating question on all the levels, the controls, the technology, but yeah, still it's going to be both.
Yeah, I understand.
So we had a few years ago, I can't remember, maybe it was 2018 or something, 100% clean energy workshop ESIG did. And I remember the two big things that came out of that were, two major technology hurdles. One was, how do you operate a power system with 100% inverter-based resources, instantaneous penetration? How do you deal with system stability? And the other one was the long duration storage or hydrogen or solution to that last 10%. And I still think the high IBR piece, we're making a huge amount of progress on, but it's still an issue. What are the specifications for grid forming inverters? What's the transition look like to getting to a 100% IBR system? How are we going to, what are we going to require for interconnection requirements? How are we going to make that happen? But I think there's a lot of progress being made. I feel pretty confident about that. I think because it's like more squarely in the realm of the electrical engineers, which I have a lot of confidence in. I have less confidence in the, what exactly are we going to do on that last 10% that's going to be affordable? And it's the affordability piece that's going to be really difficult. And then also how it's going to get built too. Like, what's the mechanism under which we're actually going to get something like that? That someone's actually going to invest in that. I mean, maybe if you're a vertically integrated utility, you can do that, but I'm not necessarily seeing how that's going to happen in an RTO. So I think probably that latter challenge of how you do that last 10%, what those technologies are, is probably going to be the harder one to solve.
Great. Thank you all. Okay, so then the first half of that question was around regulatory and permitting challenges. And we've heard a lot about some of the interconnection queues. We heard about some permitting challenges, and we've sort of seen them in our own realms. I'm sure many of you have run into that brick wall in terms of whether it's renewable energy build out or interconnections in general, or just the grid management. I think so I'll be an optimist, and I like to think about having a good target and then not knowing how you'll get there, sort of like what you described a lot in Xcel Energy, but just being able to say, what if? And expecting that if you identify the biggest, most important challenge, there can be solutions that can come out of the woodwork. So in the spirit of what if, and maybe the way to think about it is if you had a magic wand, so this is also not linked to reality. So, and you won't be held accountable because this is a magic wand and those aren't real, right? If you could change one thing and one thing only that you think would be a trigger point, sort of like CREZ in Texas that allowed not only more renewable energy build out, but easier interconnection. I mean, it had a lot of tipping points for other things to get easier in that realm. But what would be, and it can be anything. It could be things that aren't feasible from in public support or policy or political. That's not the point. It's what is your identification of one choke point that if magically it were fixed or removed or solved, it would be a big driver for improving that regulatory permitting side of the challenge that we all see as the significant hurdle here. Brave one goes first. All right.
Pick it up. I'm always good for the magic wand.
Yes.
Wishes.
Good.
One of the causes of the internet connection queues is the constantly changing analyses. And then of course at NREL, we're always trying to adjust analyses and do things better and faster and more complex and more integrated ways. And if I could have a magic wand where we could say for any grid, any type of grid under any particular condition, under any particular series of weather events you might have, like if we could be able to evaluate the reliability and stability of that system, that I think could help on the interconnection queue. So if we had that magic box, that could speed things up. It doesn't address all the reasons why those queues are slow, but it would at least knock off one of them and make our life easier.
Well, I think I did talk about the stranded asset and versus proactive issue. And I think if we could really get past that and be willing to take on that risk and to build infrastructure proactively in advance of there being generation or, in some cases load. I mean, on the distribution side, you can imagine transportation corridors where we're going to need, huge amounts of megawatts of interconnection to charge medium and heavy duty vehicles. Being able to proactively build out to some of those places and to be able to have that interconnection there for those charging stations could be a really useful way of helping to, get the electrification going, and similarly on the transmission side.
Okay, so I'm going to go down a little bit of a rabbit hole here. So when it comes to what would I want my magic wand to change inside of my company that would have a positive impact for better outcomes on the regulatory side, the way that I kind of work through it is punchline is resources. But here's how it goes. Xcel Energy has roughly 11,000 employees. Of those 11,000 employees, 8,000 of them are in our operations area. Of the 8,000 in the operations area, roughly 5,000 are field employees. They run our plants, they string the wires, they do all of the work there. So that leaves roughly 3,000 non-field employees in the operations area. You heard me talking about standing up integrated system planning. When we did the process mapping to identify who in those areas is doing planning, we transferred 160 people from operations into planning. Do the math. What percentage of people are planning the system? Is that percentage of people looking at current day system, or are they looking at long range system? Think about all the ERPs, the distribution system plans, the transportation electrification plans, the clean heat plans. You've got 160 people in an 11,000 employee area of 8 states doing 100% of the planning for distribution, transmission, energy supply, and gas. When you look inside of the company and you look at the team that is currently planning for electrification of transportation, that team is almost a team of 70. They're just doing transportation electrification. So yes, I'm being incredibly selfish right now in answering this question. But when it comes to the amount of analysis and oversight and people that are looking at in the regulatory process, criticizing, looking for holes, trying to plan, to say what it is that you're doing wrong, the models are not doing what they need to do. You have 160 people that are doing all the regulatory process, doing all of the modeling, doing all the theoretical work on looking at what that system needs to look at. So being purely selfish, resources. I need resources. That means a doubling, I would say, of the team that we have working on things right now, because the complexity of what we are trying to build going forward is orders of magnitude of just maintaining the system that we've had in the past. The tools that we are going to need have to be more robust. They have to talk to each other, but I need resources. And the complication in the regulatory environment is that they want to nickel and dime the fact that you want resources, which makes it really hard to add those resources in an environment that we desperately need them. As a subpart to that, I'm taking one more minute here.
Yeah, please.
You can add the people and you can add the resources, but the outputs from the systems that you are modeling from are only as good as the data inputs. If you go back to the 60 to 70 years of the system that we've been building, is there anybody in this room that would stand up and say they have 100% accuracy of their GIS system, of the data that they have on how customers use your system, et cetera? How about 90%? How about 80? Notice there are no hands going up in this room yet. So when you're planning for the future and you're modeling in these tools, you can add the resources, but unless the data comes along with it, as a former recovering software engineer, garbage in, garbage out. So that means we've got two layers of things that we desperately have to address in order to be successful. Because on the regulatory front, people are just looking for the gaps of what you messed up, quite frankly. And that comes back around to the acceptance of the stranded costs and the risks that you have to take and everything else. So I'd say resources and really high quality data.
Yeah, so it sounds like you almost could just invite Debbie over with her magic wand to give you the tools that have all those insights and models built in. But those are great answers. I would say, from a perspective, I think, especially with your answer, I can almost guess what this answer will be. So I'll let you go first for this one. But, in our work, we talk about this publicly, with customers, with other stakeholders, and there's almost always misconceptions. And there will always be, because this is such a fast moving space and there's so much learning that we're doing and that our communities are doing. What would you describe as maybe one of the bigger misconceptions that you've been bumping up against that you have to deal with? And I was guessing yours might be resources and what we have to deal with and what we actually have, resource wise internally, but feel free to go another direction if there's other things. But misconceptions that you've had to manage, or that you regularly have to answer to or try to form.
I'll do a high level one, but y'all heard me talk about it before. And I agree, it's resources. And that was even a learning for us inside of the company as we went through this exercise, because we hypothesized about 5% of the operations, non-field operated working areas would be doing planning work. And that's still kind of low, you would think, but we estimated to be about 5% and it ended up coming in much less than that. But the other piece of the puzzle is that I think the misconception that I run into the most in especially my outwardly facing conversations is that this is easy. And y'all heard me talk about that before, is that just because people don't understand the complexity of the physics of the system behind the service that they are receiving on this, they believe it is easy. And so they're like, well, why haven't you done it already? And why is it not in my best interest for you to do it a whole lot faster? And so those are things that we bump into all the time, is that education level and getting the ability to have the conversation about what it is that we all do on a regular basis to deliver probably the most impressive manufactured product in the history of man, which is electricity.
I'd say one of the biggest misperceptions, and I'll speak more to this room than the public, but that equity sort of solves itself as you decarbonize the power system. That we're cleaning things up and that's going to improve, air emissions and equity will be better. But there is so much to so many aspects, right? Like what's the sequencing of electrification and decarbonization in terms of rate impacts? people's ability to participate in electrification or participate in the, having rooftop solar, community solar. There are issues around, as we're imagining like investments in the community and like having really cool mobility options and clean energy options. How do you do that without risking gentrification increasing? There are issues around the circular economy of products and what are the sources of materials that go into the solar panels, or how are we storing the hydrogen? Where are we putting the hydrogen? Are we having combustion units that are running a lot and having local neighborhood impacts? So there's a lot of, without centering equity in sort of policy implementation or our studies and analyses, we won't necessarily we're not going to necessarily capture outcomes that we might want. That doesn't mean everything. I mean, our role, we look at questions in different ways. So we're not always going to center equity in every single question, but we can't not center equity at some point in some of our analyses. So it just doesn't solve itself. We have to be deliberate about what are the metrics we're using? What are the outcomes people are interested in? What are the concerns that we haven't thought about because we don't have those people in the room as we're having discussions like here at ESIG? Like, what are the other people who aren't in this room thinking? So that just takes some time and it doesn't come naturally.
Thanks. So I think a huge misperception is that times haven't changed or that people haven't changed. So there's a lot of us, we've been doing this for like 10 or 20 or 30 years or a really long time ago. We tried a lot of stuff. And there's a conclusion that we make that, we did interconnection wide transmission planning 15 years ago and nothing happened and therefore it doesn't work. And so why should we try again? Or we did demand response back in the 80s and it didn't work. So why should we try it again? It's really, people don't want to change their behavior. And I think maybe some of those ideas are ahead of their time. Or maybe we didn't have as much of a need for that back then as we do today. I think, we forget that, we used to have Palm Pilots and there was like the Apple Newton and, all that stuff failed, but everybody's got one of these today. So times can change. We can try some of these things that are good ideas now. They can work and we need to be innovative and we need to keep trying.
So those are great answers. And I think the idea that times change, people change is core, especially experts. It's easy to imagine that we know it. And so what we've experienced will always be the right answer, even though it was the right answer then, maybe isn't now. Something you said, Jaquelin, makes me want to take this on a little sidebar. You talked about equity not solving itself. And I think it's a smart way. It is something I had never thought of before, but I know it's easy for us to imagine that when you're changing a system, the evolution of that system is informed by your community, and it might not be right at first, but it will get there, right? And that's this whole concept of the community will shape it. But this is happening at such scale and with such speed that we have a chance to go down the wrong path pretty far without very active engagement and focus on equity. And it's happened before as we've built out big infrastructure. And even more recent examples, I think, are like AI algorithms where they, whether it's racial profiling or whether it's just the fact that clearly the people that developed that algorithm were representing a very small slice of our environment or our society, and that algorithm is very biased because the people that built that algorithm are biased. So with this AI thread in mind, there's a lot of AI in the news with the ChatGPT 4. I can't remember if I'm even saying that right, but it is exciting and scary and mind-blowing all at once. And I'll just, that's the pivot here is with AI. So do you see that there is an opportunity, or are we already seeing there to be either influence on models and tools or planning approaches? Is it just going to be so hard for regulators or for policymakers to trust it that it really won't be useful, even if technically it could be useful? Any thoughts from any of you on AI's influence in our sector?
I think we're trying to, at NREL, to think about how to use generative AI to fill in the gaps on data sets. I mean, you want good quality data. Can we take a step in that direction with generative AI to fill in some of the gaps that we're having. I would, one of the things we joked about with ChatGPT when it came out is like, oh, wouldn't that be cool if you could do that LA 100, but just straight through ChatGPT and you get your answers for whatever question you have. Like, all right, what's the pathway to 100% decarbonization that has the most local jobs? And it comes out, and that would take a lot of work to get there. But like, I'm definitely, thinking like, oh, it'd be really cool if, we could make our data and tools and analysis more accessible to more people, which is, I think, where the value can come in, although obviously there are all those pitfalls.
I'd like to tie this a little bit back to, what we're problem solving around, the planning side of things and how it impacts the equity. So just going down kind of a pathway, if you think about transportation electrification or more broad adoption of variable energy resources on the distribution system, and you're looking at, okay, we've now defined 2050, and this is what the system's going to have to look like. We now need to roll that out over the next 25 years. The logical pathway of doing that is going to go do predictive analytics on socioeconomic, capabilities, and go to the places where they're going to adopt the technology first to make sure you're ahead of that versus behind the curve. But then you start thinking about, well, what's the impact of doing that? You're actually improving reliability of the system where people would be more prevalent to adopt the technology. And you start going, no, wait a minute. I might also have to shift capital such that I'm not doing as much maintenance on the system because I have to do proactive replacement. And so therefore you might be doubling down on not investing in those areas that may be less socioeconomically advantaged. And that's not fair. That's not reasonable for us to deliver our services that way, where it's like, okay, where there's going to be the greatest change first, you go and invest there, you're going to increase the reliability and leave the others to wait until they come down the line. So what that means is that we have a real challenge of looking at the system, and we will have to make decisions of deliberately what percentage of the capital that we were going to use to replace a system to be ready for the 2050 environment will then have to be spent somewhere else to deliberately make sure that we are balancing the reasonableness and fairness of the system as well. That's going to be a really contentious conversation, I would expect, in our regulatory environments. And then how do you pick? What do you look at? What's the right percentage? How are you going to go about doing that? But it is the right thing for us to do. And so to me, this question, and it's a great one of facing, how do you make sure you can't assume that equity is just going to come along, right? Because there's a timing associated with it. And so then how do you make these decisions? You tied that into AI, and how do you look at the systems? I think some of that has to look at, how is the environment of our communities going to change as we shift, say, generation that has been in the middle of a community, close it and move it outside of that? How is that environment actually going to change? Is it going to change the topography of the people that live there? And so there's a lot of pieces to this of, can you use some kind of predictive analytics or AI to give you some insights on what people are going to do? Really geeky and specific right now, though, is we've been behind the curve on doing advanced metering or smart meters in the Xcel Energy territory. In fact, we just started installing them 2 years ago. We had AMR, which, you drive around and you measure, but the smart meters are just now coming in. So until just 2 years ago, we had pretty much zero visibility below the distribution substation. Like, you had to have 3 customers call to let you know that there was an outage before you could triangulate to roll a truck. I mean, it's a lot of, there are pros to this in the fact that we have much more advanced technology than a lot of utilities now on what it is that we're installing, and we don't have to replace it early or anything like that. But it's also AI, what we're finding with these new meters that have installed, and we are close to 1 million customers in Colorado now with them, is very helpful in giving us more information around how customers are using our system, which is now influencing our planning even more. So there is absolutely a place to use artificial intelligence and being able to look at the planning system and what we can use. But there is so much to overcome with this equity piece and answering those questions. And I think we're in for a big debate here in the next several years.
Did you want to add anything? You don't have to. Okay.
I think we already use AI machine learning types of techniques to predict and think about how customer behavior and load forecasting. But I don't see AI as replacing, I guess, sort of workforce functions. Like, I don't see AI as like replacing running load flow calculations for generator interconnection for utilities. And I think we still are going to need to work on the workforce piece. But AI's definitely got a really big role in dealing with some of the load data sets and understanding what customers are doing.
So, and I agree. I think you guys have all hit on where there could be benefits and where we already maybe use it. And then of course, it's a tool, it's an evolving tool that we will evolve with as well. One thing that has come up a lot, and I hope that all of you are hearing this too, because it's a rather unique thread that has kind of been through this dialogue around engagement and equity, empathy, understanding the hopes and dreams and fears of a user community or of a regulator. And I think this is not something that we always talk about. This isn't something that I learned when I was getting my degree in electrical engineering. This is all like the part that is the fabric that's going to make this work or not, which is hard because, unless you're a social scientist in the room, I should maybe do what you do. Anybody raise your hand if you're a social scientist? All right. Okay, so we need more of you, and we need to build skills that you can teach us, or that we should be sort of pulling across our teams. That's the really new thing, I think, here. And Jaquelin, maybe I'll ask you this, because the LA 100 study was a really good example of NREL in particular, which is not known for community engagement and outreach in the public, really got in and engaged in a way that I don't know that I've ever heard of before, at a depth that was maybe new for NREL. How did that get set up, and how was it supported? Or was it not hard at all? I'm hopeful.
I would say that we didn't do it well the first time, and now we have a part 2 of the study that's diving into sort of equity strategies. Like, all right, given what we learned in the first LA 100 about how you can decarbonize the city, how can we then do that equitably? And so we take that as a starting point, and then look at, for example, demand response. How do we do that in a way that doesn't penalize people who don't have flexibility and where they do their EV charging, or, how maybe there's a lot of people in a particular home, and, what are the benefits of electrifying their gas stove in an older home versus a newer home, and depending on which neighborhood and things like that. And so we did do a lot of community engagement the first time, but it was at the end of it where we were like, wow, we're so much we didn't answer. And of course, you're like that with any study, right? On any question, like you get to the end and there's a million new questions. But on that one, it was because we hadn't captured some of the data and metrics that were going to affect our analysis of equity at the beginning. We had a great advisory group, great public stakeholders, but I wasn't going out into the LA public having additional meetings beyond those stakeholder until the end, right? Until we're sharing results and stuff, but a few interim. But this second study, we hired anthropologists. We've got a lot more in Spanish. There's a lot more, not just with the community-based organizations, but with the public generally. Like it's been a lot more deliberate about the procedural justice, different ways of thinking about distributive justice and things like that. So I would say it was a great start with LA 100, but we knew we could do more. And we are really grateful that LADWP gave us the opportunity to then take on a part 2.
Fantastic. And so Debbie, when we're thinking about engagement, a lot of what I see ESIG doing is setting up a better understanding of the benefits of, say, transmission, so that you can do a study on, are there cost savings, or is it about system resiliency with the climate issues coming up, or I should say more severe weather. My understanding is that kind of insight is going to be used to help policymakers, to help people who are planning systems understand the relative value of choices. has there been anything that ESIG is doing or will do, or maybe started doing already, that is, how do you bridge from this technical understanding and creation of insight to going in front of people and making sure that there's a vehicle to take it to those policymakers or to that public audience?
Sure. So we actively try to provide education and training to a broad range of stakeholders. So, I mean, these meetings are awesome and these are great. And we have really good, deep technical discussions at these meetings. But as you say, there's a whole nother range of stakeholders where you might not really want to have this level of technical discussion, but rather sort of bring the insights and bring the results and bring the bottom line to them. And we've been doing, for example, trainings with NARUC, because state regulators are one of the key focal, state regulators. They have the purview over resource adequacy, purview around, transmission siting. But there's things that we want to, purview over distribution and what happens on distribution system resources and rates and pricing. There's things that we want to bring to those regulators. So last, I guess, 2 years ago, we had a number of trainings with them. This year, we're going to do a number of trainings with them. We reach out to folks like the national NCSL, the National Council of State Legislators, and we help explain to them like some of the findings that we had in our transmission studies, of which there's like a whole bunch of them now. We talk to FERC and participate in their technical conferences and try to, get the word out there. DOE, we work with DOE a lot as well. So we're trying to find ways to, and Midwestern Governors Association, organization of MISO states, there's lots of different venues that we try to reach out to provide kind of education on the learnings that we get from these meetings and bring to policymakers and regulators.
That's fantastic. And I'll say I plant a seed because maybe I would like to talk to you later. There's the National Academy of Sciences, the National Academy of Engineering, and National Science Foundation have all been having a very similar conversation about how to how to spread knowledge once they've done a study or if they hear about a challenge. And I think ESIG is in a position to create a lot of understanding across this very broad domain. And it would be great to see that elevation of the insights.
Actually, I've been in discussions with them already.
Okay, great.
And I know that they're interested in doing a workshop this year on, I think, more on the DER side.
Fantastic. Great. So we're almost going to get to the point where I'm asking the audience. So I just want you to get your gears turning about what questions you might want to ask. But I have at least one more for the audience, for the group here. And that is, we've got a lot of people representing the sector from very different roles across very different companies, but all here because they have an interest in this approach. And I think many of the folks in the room, I won't make you raise your hands, but I'm sure you probably agree with this, the topic of this plenary being a really important one, and that we're all kind of pulling in the same direction here, even if we're pulling on a different part of the rope. But if you had an ask of this audience for them to help or focus or address something, what would it be?
All right, I'm going to jump on Alice's one, workforce. So we need more people in the workforce. We need you to go out and inspire young people and mentor young people and get young people interested in electrical engineering and get them interested in power engineering, which, is really kind of boring. And,
In the social science of.
Yeah.
But I mean, we have a dearth of electrical engineers these days. You can't, everyone's trying to hire someone. There are no people. And we need to go and inspire young people and explain to them the importance of what this work is and what they need to, think about. There's going to be great job security for decades.
Same.
Yeah.
It's something different. We absolutely have to do the people side of this, but the other thing that I would ask for you to do is not just about hiring people, but it's sharing the message of what it is that you do and why it is important. We have this conversation with our employees all the time, and we try and arm them with facts so that when you're at the backyard barbecue and somebody's just like, oh my gosh, this is going on, I can't believe it, and it's your area of expertise, don't hesitate to share your thoughts and your perspectives. When the person posts on the next door post, I can't believe we're, not at 100% renewables yet. Explain to them, here's the pieces of the puzzle that you need to think about, right? Take those opportunities to have the dialogue. I know all your friends are going to look at you and go, God, you're such a geek. It's okay. We're an elite club. It's good to be part of it. But talk with your family members, talk with your neighbors, help share the message, because this is important for all of us to understand as a society. And you're on the cutting edge of it. So share your thoughts. I guess that would be my ask. And for those of you who are running the technology companies that are developing the tools for us to be able to model things more accurately, go baby, go.
The only thing I would add to that, because I agree completely with the idea of inspiring others and just making it clear what the needs are, is let's not forget blue collar, like the electricians, as well as the electrical engineers, the whole, spectrum of talent that's going to be needed here is pretty broad. And so if you have the opportunity to go speak at a high school or a community college or a university or a research organization, maybe don't wait to be asked. Offer yourself up, because this is also a pretty hip and cool and in the news kind of topic that people would love to have you there as well. So I'm just going to plug and accentuate what you heard from the panel here. All right.